Well, we've covered a lot of material on confidence intervals, and I want to now tackle the concept of confidence itself. And I would say, in all my years of teaching and working with people and consulting, uh, that the idea or this notion of confidence is probably the most misunderstood concept in all of introductory statistics. And so, and one of the reasons why is you have to distinguish between a couple of different things. So there is a difference between a confidence level and a confidence interval. Okay? So when we're talking about confidence itself, we're really talking about the confidence level. And this is the number. This is the, 90%, 95%, 99%, whatever. Okay? This is that number. This is the confidence level. In the same way that you had a level of significance when you did a hypothesis test, right? You have a confidence level. The confidence level has nothing to do with your confidence interval that you're computing per se. Okay? I mean, it comes into the calculation, obviously. But but you want to realize is that the confidence level is not really a statement about a confidence interval. It's a statement about the method. And more specifically, it's a statement about the reliability of the method. So the confidence level is a measure of the reliability of the method. And so one way of thinking about, say, a 95% confidence interval for a parameter would be that if we chose a whole bunch of random samples, excuse me. So let's just suppose, for example, instead of 95, let's suppose we took a 90% confidence interval from you. What this would mean is that if I used the method a whole lot of times, in other words, I drew a whole lot of random samples. So this is my first random sample, this is my second random sample, this is my third random sample, and I'm computing the confidence interval for each of them. Notice that the margin of error is staying relatively the same, right? What happens when you do a random sample is it primarily shifts the center, okay? Now, it does also change the margin of error a little bit because the sample estimator comes into the margin of error calculation. But nevertheless, the main change is that the center of the confidence interval moves. And so you can see what's happening here. For a 90% confidence interval, what that means is that if I'm taking random samples and I'm satisfying the assumptions for the central limit theorem, roughly 90% of my samples will have confidence intervals that contain the true value of the parameter. So you can see in this case, I've just created a kind of hypothetical scenario, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can see that 9 out of 10, except this one, contain mu. And of course, this is what happens on average, right? But the idea is that 90% confidence, what that means is that the method works 90% of the time. And of course, what does works mean? Well, works means that it contains the value of mu, right? That's when it's working properly, okay? So it says that for 90% of the samples, 90% of the time is referring to 90% of the samples, their confidence interval will contain the parameter value. So that's what confidence level means. It's important to understand that. The confidence level is not talking about the confidence interval per se. It's a statement about the reliability of the method. Now, People try very hard to interpret confidence intervals. And in fact, the textbook that we used to use actually gave an incorrect definition. Okay. It's important to understand what a confidence interval is. And it's important to understand what it only is and not more than that. Remember what we said way back in the second video. We said confidence intervals are estimators for the range of values we think the parameter has. And that's what a confidence interval is. Period. And if you want to add the confidence level, you can say, our best estimate for the range of values the parameter has using a method that has this level of reliability, and then you can give your confidence level. But it's important to understand that the confidence interval is only an interval estimate. That's all. Here are some incorrect interpretations. The first one is very wrong. And I want to emphasize the fact that when we're talking about a 95% confidence interval, we're actually talking about a specific computed confidence interval. Okay, so when we're talking about these confidence interval, we're talking about the interpretation of a confidence interval that's obtained from an actual sample. That's terrible. So here we're talking about interpreting a specific confidence interval. Interpreting a specific confidence interval. Okay. And here are some incorrect interpretations. There's a 95% chance or probability or likelihood the parameter value is in a specific confidence interval. Wrong. There's no chance that the parameter is in the confidence interval. It's either in the confidence interval or it isn't. Once you've taken the sample and you've calculated the confidence interval, there's no more probability. Before you collect the data, there's a 95% chance. But once you've collected the data, there's no more probability involved. Think of it maybe perhaps similar to if you were, say, rolling a die. You put a die in a cup and you shake it up. While you're shaking the cup up, there's a 1 in 6 chance that you're going to roll a 1. Once you put the cup down, okay, and you look at the value, there's no more probability. It's either a 6 or it's either a 1 or it isn't, right? Same sort of thing here. Okay, we're 95% confidence interval. This is the second interpretation. It's wrong. Misinterpretation, I should say. There's a 95% confidence interval. We are 95% confident that the true value of the parameter is in our given confidence interval. This is a meaningless statement. And this is the one that our old book used to use. It has no meaning. What does 95% confident mean? I mean, if you're interpreting that to mean that you're using a method that's correct 95% of the time or that works 95% of the time, it's okay. But if it's not implied, this is really a meaningless statement. And it's dangerously wrong because it tends to suggest this, which is wrong. So we don't make that statement, but a lot of people do. But it's really a meaningless statement. The next time somebody says that, if you ever hear anybody say it, ask them, what do you mean by that? You're 95% confident. And watch, they'll give you a stupid answer, probably similar to the first one. Okay, there's a 95% chance that the value of the sample estimates in the confidence interval. This is very wrong. Okay, the sample estimate's always in the confidence interval. The sample estimate's not even relevant here, okay? The sample estimate's the center of the confidence interval. We're not trying to estimate that. We're trying to estimate the interval that the population parameter is in. Okay, let me give you this problem. I want you to look it over. I want you to stop the video. I want you to look at this and see if you can tell which one of them are right and wrong. Okay, I'm going to assume you started it back up again. Okay, so Abe has collected data on Salesman's Restaurant. He takes a random sample of 35 days. He computes the 95% confidence interval for mu. That would be the average daily revenue over all the days that he's operating, right? And he finds this confidence interval from his sample is 3,550 to 3,802. And we want to see which one of these is wrong. There's a 95% probability that mu is between these values. No. Okay. We can't say anything about the likelihood that the true value of mu is in here. Okay. There's no probability involved in a specific confidence interval. If he took many samples, 95% of the sample means will be between these two values. No. First of all, 95% of the sample means, what we really want to say is that 95% of the samples will have confidence intervals that contain the population mean, okay? But the sample mean jumps around from place to place, and it has nothing to do with a specific confidence interval. That's clearly wrong. 95% of the sample data is between these two values. No, this has nothing to do with the sample data. Okay, we're talking about the population mean that we're thinking is between these two values, not the sample data. 95% of the time, mu will be between these two values. Well, this is basically a restatement of this. Okay, he's 95% confident that it's between these two values. And again, this is a meaningless statement. This is and unfortunate, because this is a statement that most books teach you to use, and it's simply BS. It doesn't mean anything. What does 95% confident mean? And again, it's very insidious, because it's suggesting 95% confident that mu is between these two values is suggesting, again, one of these probability statements that's wrong. So this is clearly wrong. So none of these were correct. What is the correct interpretation? The correct interpretation is that Abe estimates the true value of, and I'm going to say mu, but you could write in what mu actually is. It's between 3,550 to 3,802 using a method that has a 95 that is 95% reliable. Okay. If we really wanted to give a good interpretation of this confidence interval, this is what it would be. Abe estimates that the true value of the average daily revenue from all of his days, okay, or mu, is between $3,550 to $3,802 using a method that's 95% reliable. This would be the correct interpretation of this confidence interval. Okay, I hope that helps. Something to think about. It can be confusing in the minute, and it can be confusing for a moment when you first learn it, but hopefully if you think about this correctly, it won't be too difficult.